Good morning all. I am Dr. D. Madhavi. Today we are going to discuss searching techniques in data structures. The process of finding the location of an element with a specific key or value within a collection of elements is called as a searching. That means if you store a list of elements in an array and you are searching for a value in the array. So the value is to be identified whether the value is present or not. So that value is called as key because that is the key element for which we are searching for. The process can also be seen as an attempt to search for a certain record in a file. So in a file, each record contains data field and key field. The key field is unique and is a group of characters used as an identifier for each record. Searching can be done based on the key field. Specification of the search problem. Given an array A and integer x, find an integer I such that if there is no j, such that A of j is x, then I is -1. That is, if the search is unsuccessful, it returns -1. Otherwise, I is any j for which A of j is x, then it is a successful search. There are two popular searching techniques. One is sequential search, the other one is binary search. There are also other searching techniques which are beyond the scope of our syllabus. Similar with sorting, searching can be implemented in two cases, internal and external search. In external search, only it can be implemented if searching is done on a very large size of data. Half the data need to be processed in the RAM, while half the data is in the secondary storage. The other one is the internal search, the searching technique that is implemented on a small size of data, and all the data can be accommodated into the RAM while the searching process is conducted. For example, the data can be stored in an array, and we focus on internal search. The first technique is the sequential search. So here every element in the array, what is array? It is a storage container containing some elements. Every element in the array will be examined sequentially, one after the other, starting from the first element. And the process will be repeated until the last element of the array or until the searched data is found. The simplest search algorithm is sequential search, but it is also the slowest algorithm. So this is the process for sequential search. This assumes we are given an array A of size n, that means array A containing n elements and a key x. So we have to search for x in the array A. So for that, we have to repeat the same process for all the elements of the array. We take a for loop. For the index variable I, we are repeating the loop for 0, 1, 2, etc. up to n minus 1. So total n elements, 0 to n minus 1. So if A of I, the value of that is stored in this location is equal to X, then we have a suitable I. The location is identified, the index value is identified and can terminate returning I. If we reach this point, then X is not in A. That means the for loop is over. That means comparison for each and every element in the array is over. Then we terminate the for loop and reaches this point, this step. Then we can conclude that X is not in A. X is not matching with any one of the element in the array A. And hence we must terminate returning -1. So this -1 indicates unsuccessful search. So this is the simplest code for sequential search. A for loop. It is in C syntax. So an initialization for the index variable I with 0. And this is the condition, terminating condition. So it should repeat for all n-1 elements. So only less than symbol. And then this is the incrementation step. We are going to increment by 1 every time to have all the n-1 iterations. And what is there in the for loop? If there is a match, then return the index. Otherwise, repeat the for loop. If the for loop is also terminated, if it reaches the threshold value and if the for loop is also terminated, then it has to return -1. This -1 indicates the search is unsuccessful. That means X is not found in this array. This is an example. So initially I'm storing the index value as -1 and this is my array. I'm having 5 elements in my array. So these are the addresses of those slots, array slots, starting from 0 to 4, total 5 elements. And then these are the values that are stored in those locations, 11, 33, 22, 55, 44. And my search key is 22. I have to locate 22 in this array. So when p is equal to 0, so this 22 is compared with 11. There is no match. So there is an increment to the next location. And 33 is compared with 22. There is no match. Now the next iteration is in the for loop. This 22 is compared with this 22. That is at index 2. So there is a match. So hence the index value is updated as 2. And the search is successful. So this is the sequential search analysis. The searching time for sequential search is order of n. If the searched key is located at the end of the list and the list contains n elements or the key is not found, then also n comparisons are made. Then the loop will be repeated based on the number of elements in the list. So the time complexity is order of n. If the list can be found at index 0, then the searching time is order of 1 because only one comparison is performed and a match is found. So if there are n elements and if the key item is at the end of the list or if the key item is not available in the list, then it takes n comparisons. So the searching time for sequential search is order of n.